Good morning, ladies and gentlemen. Today we are going to start on soil formation, and from our previous classes, the study of soil, we called it pedology, and so the process of soil formation is known as pedogenesis. And the pedogenesis really is a slow, complex, and continuous process by which rocks and organic materials are transformed into soil which is capable of supporting plant growth and sustain microbial life. And in the process, a number of activities are involved and a number of transformations courtesy of the interactions of the physical, chemical, and biological mechanisms which operate over a long period of time under the influence of specific environmental conditions and factors such as rain, temperature. We also have chemicals, organic matter, and so forth. And for soil to be formed, there are a number of factors that are key, and one of the most important is the origin of the soil, or rather the parent material or the parent rock. Any soil, just like any organism, comes from parents, comes from parent material, and this parent material might be residual, which is formed by underlying rock material, or it could be transported or deposited by agents such as water, wind, ice, or glacier, or it falls by gravity from a higher ground to a lower ground. Okay, let's proceed. Just said that the origin of soil depends basically on the parent material, and we have agreed that that material could be residual from the bedrock or the parent rock, or it could be transported and deposited by various agents. Now, such parent rock determines the mineral composition of the soil, and again it greatly influences the soil texture, fertility, the color, and chemical properties. And these are characteristics of soil which we are going to discuss in greater detail much later. But however, as much as the parent rock determines the chemical composition, the mineral composition and the soil characteristic might finally change gradually due to the interaction of other processes and input of other materials such as organic matter and minerals brought from without. So the basic process of soil formation is known as weathering, and weathering can be simply defined as the breakdown of the parent rock into smaller particles and simpler compounds, and it forms the basis or the foundation of soil formation. And three main mechanisms are involved in this weathering process. The first is known as physical, which is also referred to as mechanical weathering. This involves the disintegration of rocks without any chemical alteration. The key agents include temperature fluctuations, which cause alternate expansion and contraction of the parent rock and already broken particles leading to further breakdown and size reduction, which leads to soil formation. Freeze-thaw action, this refers to the water that settles in the crevices and seams around rocks, and when water expands from the anomalous expansion of water, you understand this concept, it expands, and when it thaws, it contracts in volume, and so the alternate expansion and contraction of water in the freeze-thaw action leads to tremendous force in the breakdown of rocks. Besides that, as water moves, as wind blows over the surface, and as ice or glacier moves on the rock surface, they lead to wear and tear, and this process is generally called abrasion. And these agents greatly influence soil formation by actually contributing a greater percentage of the rock breakdown to form smaller particles, which necessitates soil formation. The physical weathering per se increases the surface area, making the minerals and rocks more susceptible to other types of weathering processes, especially chemical weathering. Then now chemical weathering, as the word suggests, it involves chemicals which alters the mineral compositions of rocks, and this takes place via a number of reactions. One of the most common reactions is hydrolysis, and we know rains and water in the Earth's crust, they play a great role, and this reaction with water leads to the formation of clay minerals. And remember also, water is a very good solvent for most of these minerals, and at the end of the day it will lead to dissolution, and as the water moves from one point to another, it transports the dissolved minerals to another place, and wherever the water moves, as it percolates down the soil layers, it will influence the mineral composition of such soil that is being formed. The other process of chemical weathering is oxidation, and it goes without saying that this is the reaction with oxygen, and there are various minerals which are found within the parent material which undergo oxidation, leading to the weakening of the soil forming materials, and facilitates further breakdown of the soil forming particles, hence making soil formation easier. And then the other process is carbonation. We all know that we have a lot of carbon dioxide in the atmosphere, and also within the Earth's crust we have a lot of CO2 being converted by reacting with water to carbonic acid. This carbonic acid weakens the rock materials and facilitates other reactions within the soil substratum to lead to further soil forming processes. Besides that, we have the third and critical process of biological weathering, and from the word biological, it implies the activities and the contributions made by the living organisms, which include the flora, fauna, and the microorganisms. Plants, by virtue of their root penetration, they lead to considerable weakening of the rock structure and leading to breakdown to smaller particles, which increases surface area for other processes to act and lead to soil formation. We also have microorganisms which produce organic acids and also bring about decomposition of organic matter within the soil, and this contributes greatly to the mineral composition and the addition of organic matter and the alterations that are necessary to form a healthy soil meant for growth of plants. There is another set of animals which are normally inhabiting the soil. They normally burrow through the soil, they live in the soil, and in the process of burrowing, they lead to the mixing of soil particles. They lead to aeration, which increases the oxidation processes. And besides that, they also break down organic matter through feeding, and they also add some organic matter through their death and decomposition, and these both contribute to the soil structure and the soil composition. And at the end of the day, we cannot overlook man as one of the major contributor as a living organism through the activities. And we have a number of activities that man do in the process of carrying out the economic activities. So man greatly influences soil in a negatively and positively. Besides the three important weathering processes, we have accumulation and transformation of organic matter, which greatly influences soil formation. Now, as plants and animals colonize the weathered material, the dead plant residues accumulate on the surface in terms of leaves, in terms of the bark, the dead wood, and so forth. We have other human activities, like now the crops, after harvesting, they deposit, or rather they leave the remnants of the crop harvest on the soil, and they are plowed back. Then we have microorganisms acting on such organic matter left on the surface or in the soil. This process conclusively leads to formation of stable humus, and the humus, as it were, is very, very important in the improvement of soil structure, nutrient retention, and it also improves the water holding capacity, besides enhancing the microbiological activity, which leads to further formation of humus. And this one is very key in the formation of true soil, which actually supports healthy growth of plants. Besides the accumulation and transformation of organic matter, we have the translocation or transportation of soil materials from one place to another, in the process leading to formation of true soil. And these processes are normally carried by agents such as water, wind, and ice or glacier. And in these processes, the most important, which are normally achieved by water, are two, which is elevation. And elevation here refers to the removal or washing out of finer particles of soil and rock, which is broken. Then we have nutrients and organic matter from upper horizons to the lower horizons. So remember, when it rains, water normally percolates through the layers, and in the process it picks some organic matter and some minerals which are soluble into the lower layers, leading to the variation of the soil composition along the layers. The next process is eluviation, which is the opposite of eluviation. So in eluviation, there is accumulation or deposition of materials which have been transported by water or which have been translocated through water to the lower horizons. And in the process that takes place over time, it leads to horizon differentiation, and in these horizons there is a variation of the nutrients and the minerals, and then these horizons in a matter of time they greatly differentiate. And in well or fully formed soil, we normally have at least 5 horizons, and these are given alphabetical letters. O, horizon, which refers to the top soil, which contains a lot of organic matter and humus. Then just below it, the subsoil, we have a mineral soil enriched with organic matter. Then after that, we have the B horizon, which is the zone of accumulation of clay, iron, and aluminium, which are the major minerals or elements in the Earth's crust. Then we have the horizon, which consists of partially weathered material. This is where you find rocks that are broken into small pieces, but they are still intact and are prone to further breakdown. Then we have the parent rock, or the unweathered rock, on the R horizon. However, from one place to another, depending on the interaction between the environment and the other soil forming factors or influencers, the clarity and thickness of these horizons may differ from one place to another, but the clearer and the thicker the horizons are, the greater the degree of soil development. Then now next we're going to talk about those factors that influence the soil forming factors. What are these factors that accelerate the soil formation process? The factors basically fall into 5 groups, and the first one is the climate. And from our former levels of education, we've defined climate as the average weather conditions of a given place over time, and the most important elements of climate or weather in this aspect are the temperature and rainfall. Temperature and rainfall regulate the weather intensity, they influence leaching, and also enhance biological activity. Climate can be described as warm and wet, cool and dry, and such. However, the warm and wet climate accelerates soil formation faster, while the cool and dry climates slow it down. Weather conditions vary from one part of the earth to the other, or the biosphere to the other, and the mineral compositions of the parent rock in various places differ markedly. Hence, the various processes of soil formation differ from one place to another. but on the baseline, climate of a place greatly influences soil formation, and that is why in wet and warm climates we have better developed soils as compared to where we have cold and dry climates. And this one is supposed to refer to the deserts, the cold and the hot deserts equally, while the highlands and the lowlands have better soils because of basically the climate conditions. The next influencer are the living organisms, especially the plant or the fauna. The vegetation type determines the organic matter input and soil protection, while soil fauna of animals and microorganisms influence the mixing, decomposition, and nutrient cycling. Living organisms, plants, animals, microorganisms, and man play a great role in influencing the other soil forming processes or weathering through the activities and through the contributions directly as organic matter. Then we have the relief of a place or topography. And when I talk about relief, this one simply means the slope. And slope directly influences drainage or water movement. It influences erosion and the depth of soil. Remember, some areas are hilly, some areas are slopey, some are flat, while some have gentle slope. And when you look or assess each of them, you can actually tell that steep slopes often have shallow soils due to erosion, while flat areas develop deeper soil profiles due to less erosion and increased deposition. The parent material is also very important, as we have discussed from the previous lesson. It determines the mineral composition and initial fertility. However, as a matter of time and intervention of other agents of translocation and deposition, it's normally modified over time. And lastly, it goes without saying that soil formation is extremely slow, and for soil to be well developed, it requires time. And so well-developed soils has taken really a long time to develop, and it may take 1,000 years to form. So time alone, as much as the agents of soil formation are active, is a key factor in ensuring or in making soil to reach the required degree for it to be called soil meant for sustaining plant life and also microorganisms.